Central European Time. We're sitting in Cologne and Wuppertal in Germany, as well as Dublin, which is where the three presentations are coming from today. And so you're aware this webinar is being recorded, so others can refer to it later. And we'll make the link to the recording available to you as well. Just some basic, say, logistical questions to deal with. Oh, just a second. Small pause, okay. If you're calling in by telephone, you can see the little mark there with the telephone, the dial-in options. Please do make sure that you use the dial-in PIN number. That means, let's say, you're muted at all times as a participant, but if you use the PIN number, then you're able to be unmuted so you can participate in the conversation. So that's the reason for the PIN if you happen to be dialing in by phone. If you're using your computer and speakers that way, then it's not a problem. The next thing is that you are muted by default, and I know we have this listed as a participation tool, but I'll just let you know the reason for that is because we have more than 80 people on this call right now, and so we've kept everybody in mute position so that we're not disturbed by a lot of background noise. But the next thing you see there is the raising your hand button, and there's a little button you can see where you can put your hand up, and I'd like to ask you to I'm being told that you can't see my screen at this point. I'll have to switch over. Just a moment. I'll do it this way. Yeah. Ha. I think we're there. Sorry about that. So phone and internet connection, as I mentioned, and the other 3 points are the raising your hand button. So I will ask you this time now, if you wouldn't mind, just put your hand up. So push that little button if you are seeing this, just to make sure that everybody got that. Okay, got some hands going up. All right. The other thing you see there is the question button, or the question box rather, and that is another way to communicate with us. Feel free to write questions anytime throughout, and we'll either respond in writing or collect the questions and share them with everybody else in the discussion time. And the last thing you'll see is the poll section, and we'll be asking several poll questions throughout the webinar to gather your input and to help you learn something about the other people who are participating here as well. And just so you know who we are, well, it's a little bit slow moving right now. You see? Okay. There we go. Ha. Sorry about that. Just so you know who's here. I know despite all these communication options available to us, it feels like a bit of a black hole sometimes when you're in a webinar, you're looking at your computer screen, but as I said, there are 80+ people sitting out here, and there are 3 of us in our office working on this right now. So we have Kristen, who's upstairs, who'll be managing the polls and questions as they come in. We also have Lasse sitting across the table from me, who's managing the computer technology, and my name is Bonnie. I'm not sure if I remember to say that before, and I am moderating and presenting a little bit about the Flow project as we get started. And so we know who you are, these 80+ people. We have our first poll question coming up, and that is, what kind of organization do you represent? And Kristen will put the poll question up for you, and we'll give you a moment to show your responses.
Okay, what do we got? Slowly getting some responses. We're at about 63%, 68. 70. Let's see if we can get everybody to vote. Let us know where you're from. Okay, we have about 80%, so I will close the poll now.
Okay.
And share the results. So it looks like most of you are from a transportation consultancy, followed by local authority. So it was 36% for transportation consultancy, 28% for local authority, and other is 25%, 9% from NGOs, and 1% from the commission.
Okay. If anybody who wrote other would like to tell us where you're from, what kind of organization you're from, or it could be you're independent. Maybe I don't think we offered university as an option, so there could be students as well. So if you want to fill that in, that would be great. And
okay, so we're getting a few responses, and yeah, tech company is one person, another one technology/solution provider. So a bit more tech focus. University of Applied Science.
All right, so we've got an idea anyway. It seems like for the most part consultancies, followed by local authorities, and then a few others. So you're aware, and you may have seen this when you registered, but this webinar that you're seeing today is part of a series of webinars and e-courses that are being presented within the FLOW project. And as you can see, circle in red, we're in the first one right now, Congestion and Your City, the FLOW approach, with a general introduction to FLOW and looking at some of the things that we've been doing so far. And there's an e-course following after this, and we have two other courses that we follow, one later in the spring and then one taking place in the late fall. So keep an eye out for those in the future. Just so you know what's coming today, we have Welcome Introductions Webinar Participation Tools. Check that off, that's already been covered. Followed by an introduction to FLOW and the portfolio of walking and cycling measures, which I'll be doing in a moment. And then the FLOW conceptual framework and key performance indicators, which my colleague Fred will present from Wuppertal, and I'll introduce him also in a moment. Some question and discussion time in the middle, and then we'll have an example from Dublin from our colleague Chris, who's sitting there, and then an overview of the FLOW methodology, and we'll come back to Fred to do that. And that will be followed by some questions and discussion at the end. So as I said, this should be between 75 and 90 minutes altogether. And the FLOW project, so this is where we are. There are tools already available, I think probably most of you know, with regard to assessing the benefits of walking and cycling. So we have the health benefits, we have the environmental benefits, we have the economic benefits. These things can be measured, and it's been done quite a bit. But interesting, since walking and cycling are modes of transportation, is one thing that hasn't been assessed and measured very well is the transportation benefits of walking and cycling. And this is where FLOW fits in. As soon as that next box comes over, it's a little bit slow again. There we go. This is where FLOW fits in, and we're looking at, when we consider the transportation benefits of walking and cycling, we're looking mainly at congestion, and this is what the project is all about. And it seems to make sense that since most of the time walking and cycling measures are paid for from transportation budgets, that we can also measure and assess the transportation effects of such measures, so the congestion effect, and this is what we're looking at now. So we have, within the FLOW project, we like to say that we brought two worlds together. And the first one we can see here, and perhaps maybe some of the consultants in the room recognize this, I don't know. So transportation modeling, it's taken very seriously. We're predicting and providing for future transportation needs, whatever that may be. And often the model says we need another highway. But there's also the other world, which is cycling and walking, which are playing a larger role in people's transportation choices these days, but often are not, say, not taken seriously necessarily as real modes of transportation, and as such are not necessarily assessed, so the effects that they can have. So the challenges that we face with this, there are several. So one of the main ones is defining pedestrian and cyclist congestion. What does that look like? What is it exactly? We have a lack of data which I imagine a lot of you, particularly consultants, will have found. How do you manage this when you simply don't have the data you need? Next, modeling human behavior is simply difficult. So it's a challenge that we face all the time. And then proving that the congestion reduction was actually a result of the walking and cycling measures is difficult as well, often coming back to the data because it hasn't been assessed before and after. Then we have also a cultural bias toward motorized transport and the lack of political understanding and support. And these are all aspects that the FLOW project is trying to deal with throughout the course of our project runtime. So the question now is, what is multimodal congestion? Or that's one of the questions, I suppose. You can say, for example, I don't know if this is multimodal, you see motorcycles and you see cars. So there are two modes of transportation, you certainly see congestion. But what about this? Bicycle congestion, as we can see from Amsterdam, or we have pedestrian congestion, as this London example shows. But what about the other half of this picture now, when we say there's lots of space for the cyclists, but there's congestion for the motorized vehicles? Is this congestion or is it not? And these are part of the questions that we're dealing with in the FLOW project. So pedestrians and cyclists in planning and modeling. This is one of the key things that we're looking at in FLOW. If we talk about the role that cyclists and pedestrians play in transportation, then we need to look at modeling them as well. So how do we take them seriously as modes of transportation? How do we model them? So as you can see, or you can see here in the picture, PTV is a modeling company that is part of the FLOW project, one of our partners. And they're working on both strategic planning, so macroscopic modeling within the FLOW project, and walking, so which means walking and cycling in transport development plans, so at the high level. We're also within the project looking at operational planning, which is at the microscopic level, so the interactions with other modes at intersections. So for example, how do cars and pedestrians interact, or how do cyclists and pedestrians interact? So all of the different possible combinations that are possible at the operational level. And active modes of microscopic modeling. What we should say, I suppose, is a model is, I mean, you can think of Lego as being a model too. So a model, just like Lego, is a representation of reality. And while it's a simplification of the world, the idea is to get as close as reasonably possible to representing reality, given the available data and the capacity and resources that you have. So we'll see simulation planning, as we'll see a later example of that coming up. Specifically looking at the microscopic modeling and what's happening within the FLOW project, what's being developed. PTV has updated its microscopic model in the 4 ways that are listed here. So by enhancing the modeling of conflict zones between cars and pedestrians, so it's modeled more accurately, more reflecting of reality. Behavior parameters and new mobility patterns. Also the interactions of bicycles and pedestrians, and interesting and very challenging is shared space. So how do you look at the interactions between the different vehicles, between the different participants in transportation and shared space? And the updates or changes that are being made to the PTV model at the macroscopic level is things like bike assignment, so the path level attributes in stochastic assignments, so the slope or the attractiveness attributes. What do cyclists find attractive? Which routes are they likely to choose based on slope or based on traffic numbers and various other things? There's also park and ride modeling, so it's actually a modeling platform for the combination of 2 path legs, and that can also be used for walking and riding or for other combinations. So this idea of putting 2 modes together at the macroscopic level. And then the other aspect is bike sharing, and it's not just sharing in itself, but as an enhanced mobility sharing as part of public transport. So not cycling on its own, but how it contributes to public transportation, again, looking at the macroscopic level. And one of the components that the Flow project has, or one of the things that we have created, finalized already, is what you can see here is the front cover of our what we call our portfolio of measures, the role of walking and cycling in reducing congestion. And for this document, we examined 20 walking and cycling measures that have been undertaken across Europe and in some cases beyond in recent years, looking at them in the context of congestion reduction. So, and I can say with one exception, the cycling highways in the Netherlands, none of the measures that we looked at was actually carried out with the aim of reducing congestion. But of the 20 measures that we looked at, 10 of them were found to have decreased congestion. 8 were found to have a neutral effect, so neither increase nor decrease in vehicle congestion. And 2 showed a minor increase in vehicle congestion. So just to repeat that, it's really interesting, I think, looking at things that have been done for walking and cycling with no intent to have an effect on congestion, was in fact reduced. So I can say also with 5 of the cases which showed reduced congestion, they were infrastructure measures were applied. In 3 cases, traffic management measures were applied, and in 3 others, mobility management measures were applied. So it's a range of different things that were done that were all shown to decrease congestion. And almost all cases of the 20 that we looked at showed additional benefits, such as a shift to sustainable modes or an improvement in safety. So we could say from a transport perspective, the congestion reduction was a positive, and the others could be seen as co-benefits from the perspective of congestion reduction. So on the other hand, these other effects are interdependent and can help reduce congestion in the long run. So most of the walking and cycling measures that are described here have the potential to encourage behavior change and therefore in the longer term increase the modal share for walking and cycling and decrease it for motorized transport. And just one more look within this document, our portfolio of measures. I've just taken a couple of points out of this. We divided the different types of measures that we looked at into different categories. And so what you can see here, or looking down the left column, we have walking infrastructure, and just one example so you can see. This is Strasbourg, where they reshaped the roads, giving much more space, significantly more space to pedestrians at a certain bridge leading to the city center, and found that there was no increase in congestion for cars. We also have cycling infrastructure measures, so there's walking infrastructure for moving traffic, cycling for moving traffic. The same, we also have, as said, the traffic management strategies and mobility management. So infrastructure for non-moving traffic includes things like bicycle stands or benches and squares, for example, and traffic management, traffic signals, access restrictions, and mobility management, for example, campaigns that we looked at. So it's worth taking a look at this portfolio to see what sort of activities are undertaken there. It could be that there are things there that you are doing or have done in your city, and they may be having an effect on congestion, which has been unplanned, so positive but unplanned. And that's just about all I have to say for the moment. I would now like to introduce my colleague Fred from the Wuppertal Institute. Frederick Rudolph is a project coordinator with the Wuppertal Institute, where he carries out tasks such as scenario development, baseline development, and business as usual development and evaluation, and monitoring of policies and measures. And Fred, if I can turn it over to you.
Yes, you can. Please do so. So, warm welcome from my side as well. As Bonnie mentioned, I am Fred from Wuppertal Institute, and I will now present you what we call the Flow conceptual framework, which is an overview of what we are doing in terms of impact assessment within Flow. So the impact assessment of walking, the impacts of walking, cycling measures on congestion. I will do this in a minute. Before I do this, before I introduce you to our Flow impact assessment process, I would like to show you some results of the survey that we did within Flow project at the beginning of the Flow project. So what we did, we asked walking and cycling experts and congestion experts about the role walking and cycling can play to reduce congestion. And as you can see from the figure, many of the experts that we asked said, yes, walking and cycling can play an important or even very important role to reduce congestion. And walking and cycling does not play an important role to increase congestion. And if you compare this to the actual implementation of congestion reducing walking and cycling measures, this is the graph that you can see now. So basically we asked the experts, the same experts, how often walking and cycling measures are introduced to relieve congestion. You can see that many said no, they are not really often, or maybe only sometimes introduced to relieve congestion, and often they are not implemented because there is a perceived risk to increase congestion. So there's a gap, an implementation gap. On the one hand, there is, as you can see from this graph, a big role, a potential to decrease congestion, to reduce congestion, but those measures, they are not implemented.
Brett, can I interrupt you for just a second?
Yeah.
I would like to ask the audience participants a question, if I could. We'll just do a raising your hand, if you wouldn't mind, to say if you have done this. So if the answer is yes, have you in your city implemented any walking or cycling measures with the specific aim of reducing congestion? So it's probably the easiest question for if you work for a city, but the question again, have you implemented any walking or cycling measures in your city with the specific aim of reducing congestion? Kristen, do you have any?
Yeah, right now we have 4% of our participants' hands raised. Now
Okay.
5%, so it's steadily increasing, but it seems like it may be quite a small percentage.
Okay, so that is what we heard from our survey as well. On this slide, you can see a typology of walking and cycling measures that could reduce congestion. Bonnie already introduced that. This is part of our portfolio of measures, so we could introduce infrastructure for moving traffic, for non-moving traffic, traffic management strategies, mobility management policies and measures, so those that relate to a modal shift. And now, next slide. So basically, what we do within Flow and the impact assessment is, on the one hand, we try to answer how can we measure congestion. So that relates to the, if you look at the graph, at the figure in the middle, the upper part relates to the mobility impacts. So in our Flow impact assessment, we measure congestion. That relates to the transport network performance, but what we also do is measuring other benefits arising from walking and cycling measures. This is what Bonnie has mentioned as well already, so further impacts, environmental, societal, and economic impacts. And of course public financing plays a role as well, so the cost for infrastructure maintenance and operation of those measures. So on the left-hand side, we have two impact assessment tools, the congestion impact assessment and the socioeconomic impacts. With respect to the congestion impact assessment, we have developed 3 key performance indicators, and they will be part of this webinar, and I will explain them, how they can be applied in this webinar. This is the left-hand side of the figure, and as regards the socio-economic impact tool, we have developed 16 impact indicators, which I will now introduce in brief, but the application of those 16 impact indicators, this will be part of the second webinar that we are doing in May this year. So you can see on this slide an overview of those indicators, the 3 performance indicators, delay, density, and level of service. We call them performance indicators because they describe the transport network performance, and the 16 impact indicators. So there's one mobility indicator as well in the impact assessment tool relating to mobility impacts, but there are also other 4 indicators relating to environmental impacts, 5 relating to social impacts, another 4 for the economic impacts, and then 2 that relate to the cost avoidance of walking and cycling measures. So we always compare with a walking and cycling measure scenario to a without measure scenario. So you compare those indicators in 2 cases. And if you do so, then we hope to support decision making of local decision makers mainly. So this is what you see here on the slide, the policy cycle of urban transport measures. It's an ideal one. In the real world it might look a little bit different, but just to show how we want to support decision making. So we have a problem that could be congestion, but it could also be noise or whatever kind of other problem. But let it be, for this example, congestion. You put congestion reduction on the agenda, which is the second part of the this policy cycle, and then obviously you would consider to implement walking and cycling measures. And in this stage, our 2 congestion impact assessment tools enter the equation, come into play. We can calculate transport network performance with 3 performance indicators, which are delay, level of service, and density. And it depends on the level of assessment which one and which ones you can choose. So I will explain this later a little bit more in detail. If, for example, there is a junction where the traffic light is rephased, you can choose delay and level of service, all measures that relate to a corridor as well. And if you want to analyze impacts of a measure that relates to a certain segment between 2 junctions, you would be able to choose between level of service and density, or you can also use both as performance indicators. All right, and then there's also, again, there are 16 impact indicators, which will be part of the second webinar. I will explain this later in the second presentation a little bit more in detail. Just one slide about how modeling fits into this impact assessment. Basically because transport models provide input data for the impact assessment, so you can calculate travel time, and as a consequence of travel time you can calculate delay, you can calculate density, those 2 performance indicators. But based on those performance indicators you can also obviously calculate other impact indicators such as CO2 emissions, local pollutants, economic and social indicators. So that's the role of modeling within Flow. The figure on this slide shows you the 2, let's say, kinds of models that we are applying. Bonnie mentioned that already as well. So on the one hand, on a strategic level, you can use macroscopic models, which often include this 4-step calculation process, beginning with trip generation and destination choice, modal choice, and route choice. And if you want to assess a certain junction and the traffic flow at a certain junction or segment, then the microscopic model comes into play. So in our case, this is PTV vSeam, vSwalk, providing a traffic flow model. Yeah, some words about data requirements. So transport models provide a good basis for data, but obviously those models, they need input data as well. And obviously there could also be the case that the city does not apply a model. So local statistics do play a role, traffic counts, household surveys, and other statistics as well. And obviously budget considerations, last but not least, they may be relevant as well. I have mentioned that we have 2 out of those 16 indicators of the first socioeconomic analysis, which calculate investment cost and operational maintenance as well. So we can calculate whether the walking or cycling measure which is under consideration is in line with the municipality's household.
Fred, sorry,
Yeah.
it's me again. Just before you move on, I was wondering, just coming back to your budget and data slide, with regard to the data, I had a question for the audience as well, and I was hoping to get some input. If you wouldn't mind writing in the question box an answer for us, it is, what other data sources, if any, do you have access to? So you saw, do you want to go back to the last slide, Fred, and show the list that you have so far?
Yes, I can do. I can try at least.
Sorry about that. I didn't mean to throw you off. The question was...
All right. Try to find the slide again.
So you have a list of data sources that we've been using or that we recognize as being available within Flow, and I just wanted to know if anybody had anything to add to that, and if you wouldn't mind putting it into the question box as an answer for us, that would be great. I'll just give you a few seconds to write anything down. If you have any ideas or something that you use for walking and cycling data beyond what we have here so far.
Okay, we have one response from John Paul Fitzgerald. That's mobile phone data. Oh, now they're really rolling in. I'll just say them. Navigation data, tracks, GPS data collected during cycling promotion campaigns, travel apps again, mobile apps collecting trajectories, actual tracked user data, multimodal traffic count data, mosaic data, and propensity to cycle data, Bluetooth data, AVL data, and traffic master data.
Okay. Thank you, everybody. We will, in addition to the presentation, we'll make sure that all of this gets collected and put together so that that information that's coming from all of you is available to everybody else, after the webinar as well. Sorry, Fred, go ahead.
Sounds like a huge database. Yeah, this is just last slide showing the process, the impact assessment process in a nutshell. So we have walking and cycling measures on the left-hand side. We have those 4 categories already introduced. You could categorize it in a different way, obviously, as well. So, and then we have 2 impact assessment tools. The one is to calculate congestion and transport network performance, because decision makers fear congestion, may put or have put congestion on the agenda. And our second impact assessment tool relates to the wider economic, socioeconomic impacts, which often cannot be measured properly. So we have a multimodal assessment. On the one hand, 3 key performance indicators, delay density and level of service, and the wider cost and benefit impact indicators. And we hope to facilitate implementation of walking and cycling measures by providing these 2 tools. And yeah, I think this is the overview in a nutshell. And if you have any questions about that, then now it's time to ask them. Thank you so much for the time being.
Okay, thank you, Fred, very much. So we've got 2 options here. If you'd like to, you can type your questions in and we'll see them that way. Or if you want to raise your hand, then we're happy to unmute you so that you can ask your question out loud to the group.
Okay, it looks like we have one hand raised. We do also have one typed question,
Okay.
but perhaps first we can call on Matab Joy. I really hope I did not mess that up. So let's unmute you right now.
Hi, this is Mahtab from DINIC. I saw that in
Hi.
your safety measurements, you have number of killed and injured people. But there are more subtle safety measurements, like number of red light violation, people who pass the red light, and maybe they don't injure, but still it's a safety measure. May I know if you consider that, or if you didn't consider that, why is it the case?
Okay. So first of all, thank you for your question. And as I have mentioned, this part, so those 16 impact indicators that we endorsed for the second flow impact assessment tool, this will be part of our second webinar. What I can say now is that we had a long list of indicators. It was more than 100 indicators relating to all those socioeconomic aspects. And what we did then was in an iterative process of internal discussions, literature review, and also discussions with other experts, cutting them down to a short list of what I would call feasible and reasonable number of indicators to represent all different dimensions of impacts. And we finally decided to have 2 traffic safety indicators, so those 2 that you can see in this list, number of killed persons and injured persons. Yeah, so that is still, I mean, sure, you're right, matter of discussion, but we finally decided that these 2 are the best to represent traffic safety.
Okay, we'll consider that answered, and to say, as Fred pointed out, that we'll be going into more detail in that direction in the webinar that's taking place in May, so we hope you come back. Are there any other questions, Kristen, to take right now, or shall we move on?
Yes, we've gotten a few that have come in. There's one question about how much time does it take to apply our 2 tools? Sort of an estimate.
Okay, okay, I can show you. Well, how much time does it take? Let's take this slide as an answer. I mean, data is always, I think, the most crucial point. If you have data available, then I would say it's quite easy, because we have provided an Excel sheet, so we will provide an Excel sheet, for example, for the second impact assessment tool, and we also have models, obviously, macroscopic models and microscopic models, and those models, they are really able to calculate delay density and level of service. So if you have models, and if those models run somehow for your city, for example, if you're a city representative, or for the specific case which you are analyzing, then obviously it only takes you 3 clicks and you have the result. But to run those models, I mean, I have to say, yes, that can take time to calibrate those models. You can also use spreadsheet calculations, and we provide basis for those calculations as well. So I would assume if you have the data available, then it's just a matter of minutes or hours for the calculation.
We should also say too that, just to point out that PTV is our project partner in this, but it certainly doesn't work only with PTV modeling products. So this is something that would apply to, I would assume, any other as well, or other comparable.
So, I mean, the macroscopic strategic models, there are different solutions which yeah, they will be able to calculate delay and density and level of service elsewhere. These are standard indicators.
Okay. Kristen, maybe we'll take one more question now and then we'll continue on and we'll have time for more questions at the end as well.
Sure. Well, we have one hand raised and one written question. Perhaps we can go with the hand raised so we get some more interaction. So this is from Yelena Burkovic. You're unmuted. Yelena? Okay, her hand is down. So that's, we can go on to then the written question, a quick one. So Enrique Pindado has asked, have you planned data input from connected citizens? And connected citizens is the concept to show how, as example, data can be gathered from GPS-equipped bikes or gathering data from travel planning apps. Basically, how is this data being used as input?
Yeah. Well, first of all, the question which data we should use is depends on the measure that is under assessment, which is under analysis. So if you run a macroscopic strategic model, I would say if you have those app data available, that could feed into this model, for example, and that could also feed into the spreadsheet calculations for travel time, for example. So I think there is different kinds of data which could feed into the impact assessment, and certainly those apps they help with the analysis and the calculation.
One thing that is also available is I could say two of our cities, Budapest and Gdynia, are participating simply in the European Cycling Challenge, and they get the heat map data coming from that, and they're using that data as input to their models as well. So that's one concrete one that I'm aware of. Okay, I think we probably should move on. As I said, we'll have some time for questions at the end as well. But I would like to move over to Chris in Dublin. Dublin's another one of our partner cities in the FLOW project. I didn't mention the other ones, which are Lisbon, Munich, and Sofia, Bulgaria, together with Gdynia and Budapest. And we're turning the screen over to Chris, but it looks like we can see his email. Chris, I think you must have the wrong monitor showing right now. That looks better. And we also cannot hear you. I'm not sure if you've muted yourself, Chris, but if you have, you probably best unmute yourself.
Good afternoon.
There we go. Go ahead. Thanks, Chris.
Yes, my name is Christopher Manzera. I work with the Dublin City Council, responsible for sustainable mobility and projects. Dublin City has a population of 553,000. We have mode share targets for public transport, cycling and walking, as well as significant aspirations to significantly reduce travel by car. In terms of the data that we collect for mode share, is based on 33 gateways into the city. And our test site, which is part of the FLOW project, is effectively in the center of the city, which is zoomed into the screen to the right. Dublin City, like any of the major cities, experience significant levels of congestion, and this tends to have significant impact on sustainable mobility in terms of travel time and journey times. In Dublin, we map congestion areas, and we have a typical congestion map there, and this is based on the Dublin's public transport interface module. With the orange, the bigger the dot, the higher the congestion levels, with the orange showing congestion experienced as a bus leaves a bus stop and as it approaches a particular bus stop. And in this particular area, Delia Street is an approach to College Green and experiences a significant congestion. Now, translating those, that spatial presentation, the image there shows exactly what congestion looks like. Several buses stuck in traffic, and essentially resulting in increased air pollution and significant delays for passengers. This particular bottleneck is at College Green is, I suppose, a major contributor to the congestion in the city center. And as you can see from the layout there, it's actually a pinch point with several roads converging in the College Green area. When we started looking at the flow project in 2014, we had the layout for College Green, which had a median in the middle, and proposed a light rail project, which is shown on the image to the right of the screen. This proposal essentially, whilst providing for additional sustainable transport, would result in increased conflicts between the various modes, buses, pedestrians and cyclists, the trams against the pedestrians and cyclists, and also the cyclists and pedestrians. We looked at improving the pedestrian facilities in the area by providing more pedestrian space, and this was essentially proposed through rationalizing the pedestrian areas, but even with this, some of the conflicts still existed. The space for the pedestrians was still defined by traffic movements, and we're still experiencing delays for buses based on this layout. Though we had improved pedestrian areas, there were significant concerns raised in relation to the cycling provision, and also we have statues in the area that we would need to relocate in order to make this particular alignment work. So with these problems, we then reviewed the proposal again, and we came up with this proposal, which is the current proposal. This proposal will require rerouting of buses, and essentially along the 4 routes that are highlighted there. It will significantly result in reduced conflicts between the various modes. This, I suppose, is a photo montage showing how the area is now proposed to be transformed. This will provide, I suppose, continuity of the pedestrian areas, wider pedestrian crossing points. Buses will now be limited to the north-south axis, and taxis can now operate along the buses and trams, and also the monuments in the area will now be retained. Now, to get to this stage with the project, we have had to go through a series of public consultations, and to date 17 rounds of stakeholder consultations have taken place. There has been general support for the scheme, particularly the cycling elements and the creation of a pedestrian area. There is also a strong desire that if we are developing this area, we segregate the cyclists from pedestrians, and this is a item that we have had several discussions with the other stakeholders, including international representatives like the European Cycling Federation and Walk 21. There have also been concerns in relation to the impact on the overall network, particularly with some of the bus diversions that would be proposed, as well as the economic impact to businesses in the area. Now, in terms of developing the proposals, we would have done a series of traffic modeling activities. Now, the traffic modeling would be based on a Greater Dublin area demand model, and which incorporates the changes that are actually proposed for the city center. The certain model is the one that we use in Dublin, and the traffic volumes generated from this macro model are then used in the micro modeling scenarios. And for College Green, there are several micro-modeling software that you can use, but for College Green and as part of the Flow project, we are using Vism as outlined earlier by Bonnie. So in terms of the modeling itself, traditionally we have modeled for vehicles. We haven't modeled for pedestrians, we haven't modeled for cyclists. So when you look at an area like College Green, where we are proposing to provide significant measures to promote walking and cycling, the question becomes, how do we justify all these measures given that the city is already experiencing congestion? There's already congestion on approaches to College Green. So if you are coming up with a proposal, which is a transportation scheme, how then can you justify it in terms of providing for more pedestrians, and how can you justify it in terms of providing additional cycling capacity in terms of the overall utility for mobility? So that was the biggest challenge, and trying to come up with the tools that we can use to evaluate the scenarios that we're looking at, but also to being able to communicate to decision makers the benefits of what we are trying to do, not just from a public realm point of view, but also from a mobility point of view. So if you look at College Green, there's 6,600 cyclists at the moment, 85,000 pedestrians. So the total of those two is 90,000. And then when
Chris, I'm not sure if you can hear me. You've just frozen for a second there. I hope it'll come back. We'll give him a second to come back. But I would, oh, go ahead, Chris.
Yeah, okay. So what we did for College Green is we selected a significant area to do micro modeling, which is highlighted on the drawing there. We would have gone through the calibration of that model against existing traffic flows, developing a pedestrian matrix, things that would normally not be done before. And then with the various, we looked at 12 options, layout options for the area, and we're doing modifications, remodeling, and these particular areas we had to try also and mimic cyclist behavior in the models. And as well in this area we have about 20 junctions that we had to model, which is an unusually large model for micro simulation, and then trying to link that onto the adaptive urban traffic control system that we use, which is SCATS, and then doing the dynamic assignments for this. So what I will try to do is maybe switch on to another screen and run the model for you, and you can see how the modeling exercise plays a role in the decision making process.
Okay, Chris, while you're switching over, it just occurred to me, sorry, I can show myself again, that you asked a question. Go ahead and switch over as you need to, Chris, but you pointed out that before you'd done your work on College Green, you didn't know how many pedestrians and cyclists you had. And we'd like to ask the question of the audience. The question is in fact just for the cities, though. I'm sorry to do that, but people who represent cities or who know about, about the cities they're working in. The question to you is, we have two questions. The first one is, do you model cycling? So while that's being set up, Kristen will put the poll up for us. So the question is, do you model cycling? You can see what your possible options are.
Okay. We have about 30% now have voted. Slowly creeping up. Almost 50%. Give it a few more seconds for you to get your vote in. Okay, we kind of leveled off at around 53%, so I'll close it and share the results. And it looks like most have not modeled cycling. Vast majority, 47%.
Okay. I guess I'm not too surprised. I just was curious. The next question, though, I'm almost afraid to ask. It's probably going to be even worse, but the question this time is, do you model walking? So the same question, but this time referring to walking. Do you model walking in your city? And again, the question is intended for representatives of cities, but if you're from a consultancy and know what's going on in the city that you work in, then feel free to share your responses as well.
Okay, up to about 50% right now.
Mm-hmm.
Slowly rolling in. Okay, it's about the same amount have voted again, so we'll share these results, and it's 51% no. Even more.
Even more.
Yeah.
Yeah. And this is, of course, one of the issues that we're dealing with in the project simply is the lack of data that people have, or the lack of information so far about walking and cycling, and the attempt to put active modes of transportation on a level playing field with vehicle traffic. So motor vehicle traffic is a challenge when we simply don't have the data that's needed about those, or they're not included in the transportation models. One other point I will make, in case you're considering this in your city, you'll notice that we carefully separated the question for walking and for cycling, because they're separate modes and they have very separate needs too. And we've learned this many times from one of our other partners, Walk 21, who carefully says you can't just simply say walking and cycling. So if you're considering it, then do be sure that you're counting them separately so you know what's going for each of those two modes. Thank you for your responses to that. Chris, how is it looking over there? Do you have the video going for us? We've got a short simulation I know you wanted to show.
Yes, thank you very much, Bonnie.
Okay. And we can see your screen again. I hope it's going to work.
Okay, can you all see the screen?
Yes, indeed.
Okay, so we would have carried out a micro simulation of the entire area, which is shown on the video that's running on the left of the screen, and as outlined earlier from the tool that we have, you can also assess the air quality and noise impact of the measures. So on the right there, we have a spatial representation of the actual impact on air quality. In this particular case, is the nitrous oxide. And what we would have found as we were developing this particular model is that when you start looking at it, as you develop it, you start to establish the actual relationships. And if you look at the pedestrian volumes going across the road, you start questioning whether they're actually providing sufficient space. And what actually happened earlier in the models was the model was crashing because the pedestrian areas were getting congested and pedestrians were literally falling across the curb onto the road. So when you are having a discussion with people from the arts and conversation side whose particular interest with the monuments, we have the architects, we have the traffic engineers. By looking at everything and running a model at the same time, everyone could understand how the area is intended to function. When you remove some of the movements, you can see where the benefits are accruing. So I suppose what you can say in terms of the options, it will assist the multidisciplinary teams to understand how the area will function. And in this particular case, it enabled discussions to take place on the same platform between different stakeholders, people from different backgrounds. Now, so I suppose when you have gone through that entire process with the modeling, traditionally this would be a departure from tradition that we are focusing more on pedestrians and cyclists. And I suppose the question that would be putting across is, if you are taking out streets that are being used by cars, can you justify doing that and at the same time say that you're reducing congestion and also improving the overall mobility?
Okay, Chris, you're asking a question, and I would like to put your question again to everybody else. Kristen, if you want to put the question out, we have our fourth and final poll question, and it's to you. You've seen what they've done in Dublin, creating the space for pedestrians and cyclists and taking it away from motor vehicles. Do you think it would be possible in your city to remove vehicle traffic as a means of achieving improve mobility and reduce congestion. So Chris's question, we'd like to put to you in the form of a poll. Definitely, probably, to a certain extent, I doubt it, or no way. So what do you think the response would be from your own city? How are we doing, Kristen, for responses?
Okay, now I'm back. There was a problem with my audio. Can you hear me now?
Yes.
Yes, okay, good. Well, we're around 60% who have voted,
Good.
and they're slowly coming in. I can also say some people are typing some questions without the political will, or not questions, but comments.
Comments.
Without the political will, motorized traffic will always have higher priority. That's Hannah Diane. And Matab says probably to a certain extent. Now we're up to 65% who have voted, so I think we can close this poll and share the results. So 65% said probably to a certain extent. That was by far the most popular response. Not so many are confident, though. Yeah.
I have to say it's maybe better than I even expected. I would have expected more on the I doubt it answer. So, and we only got 2% who actually said no way. So interesting. Okay, thank you for your input. And if you'd like to add any follow-up comments, as a couple of you did, then feel free to do that. And we'll incorporate those and also share them with everybody after the webinar. Chris, thank you very much for your presentation on Dublin. It's I'm impressed every time I see this and see what you're doing and creating the space that you're creating, and the number of people that you're trying to get through the city center is just incredible. I think we'll go back now to Fred, who's going to give us, or continue his presentation to give us a second presentation, we can say, on the flow methodology. So I think the screen should be going over to you. We can see it already. And we'll turn it back to you again, Fred.
Yes. Thanks, Bonnie. So I am now leading you through the congestion impact assessment methodology, those key performance indicators that I already mentioned. Okay, you can see my screen now, the presentation. Yeah, so that methodology basically consists of 4 steps. First, we define congestion and transport network performance in a multimodal way, because we said congestion in a traditional sense mainly related to car traffic. Then we operationalize this definition by selecting key performance indicators, and I already mentioned this is delay, density, and level of service. Third step would be to calculate and aggregate those KPIs. And then last but not least, we have to determine a multimodal congestion threshold. And this is necessary to understand whether the measure which is under analysis will lead to more congestion as compared to the without measure scenario. So just a reminder, we in the flow impact assessment, we now speak about the mobility impacts and the impacts on transport network performance and congestion. And this is our definition. So I will read it and explain it in parallel. Congestion is a state of traffic affecting all modes. That sounds plausible, but it's not that simple as it looks like. Bonnie already mentioned it and showed you this picture where maybe you remember it. There was one cyclist on an empty cycle path, and then next to that there was a crowded lane with motorcycles. So do you consider this as congested or not? And we say yes, that is congestion. So if there is one mode congested, then we speak about congestion. But affecting all modes means also that the sum of all modes somehow, so the multimodal aggregation of all modes, that should also be assessed somehow. Because if you want to compare a with measure scenario to a without measure scenario, we have to have a final result whether the state of traffic flow before and after is congested or not. So it's one mode can lead to congestion or can be congested, and the sum or aggregation of all modes can be congested as well. And this multimodal transport network is characterized by high densities and overused infrastructure compared to an acceptable state across all modes against previously agreed targets. So this formulation points to the fact that we wanted to provide city-specific solutions, because in a city, for example, usually this assessment is made during peak hour, and it may happen that a city says, well, a certain time span congestion on certain segments is even a desired traffic state, because it's for some reasons congestion maybe, at least for some minutes, maybe a desired state of traffic. Other cities may say, no, we don't want to have congestion at all. So we want to adapt our methodology to the city's specific circumstances, and therefore we say all modes must be compared against previously agreed targets. So that's the previously agreed targets formulation. And this congestion may then lead to delay. And we say, you can read this in brackets, perceived or actual delay. With this formulation, we point to the fact that walking and cycling are active modes. And as compared to car drivers, pedestrians or cyclists, they may have as a purpose for the trip. The purpose for the trip may not only be the reaching of the destination itself as fast as possible, but as they are active modes, the walking itself or the cycling itself may be a purpose. For example, a pedestrian may like to make a detour because he likes or she likes the atmosphere of a park. That would increase the travel time. This is what we call acceptable travel time somehow. So the increase of travel time is acceptable because they like to go, they like to walk, and they like to cycle. I will come back to this later. So we include the user perspective as well here in our definition and in our application of the calculation. Second step is this operationalization with key performance indicators, and those indicators, they do not fall from the blue sky. We have used technical guidelines, so you can see here the cover at this slide. You can see the cover of the American Highway Capacity Manual and the German Highway Capacity Manual. So those indicators, they are endorsed within these guidelines as well. And again, they are delay density and level of service as a derived indicator from delay or density. So delay is defined as the additional travel time experienced by a traffic participant as compared to the minimum travel time. And we say minimum travel time, we do not say ideal travel time, because we want to include this user perspective. So the fact that somebody, for example, a pedestrian, wants to make a detour because of the great atmosphere of a park, or a cyclist wants to make a detour because he or she wants to take dedicated cycle lanes for more traffic safety, they may increase their acceptable travel time as compared to the ideal travel time. So the ideal or the minimum travel time would increase, and that would decrease delay, because the minimum travel time, the difference between the actual travel time and the minimum travel time is decreased. I think there will be a lot of questions about that. You can ask them later, and there will also be an e-course starting tomorrow where we can discuss this a little bit more in detail. For the time being, we can say we have included the user perspective into the KPI delay. Then density, it's a measure of the number of persons or vehicles using a given space. And LOS, it reflects the quality of service experienced by traffic participants. And it's usually given in distinct classes. So delay or density, those measurements, they are transformed into 6 classes, whereas free flow is class A, if you like. The best class is free flow conditions, and then LOSF is the breakdown or congestion. So that's the 6 classes which are given and which delay and density is transformed into. When do we use those indicators? In case of a junction, this is the upper table now that you can see. So there are different assessment levels, and in case there is a junction under the assessment, so the measure relates to a certain junction, which for example could be the case if we reallocate green times in favor of pedestrians or cyclists, then we can apply the indicators delay and level of service. In case we have a segment between 2 junctions, which would be the case, for example, if we introduced a speed limit of 30 kilometers per hour to this particular segment, then we would use density and level of service as indicators. And in case we have a whole corridor as the sum of a number of junctions under assessment, which would be, for example, the case if we introduce a new cycle path, then we will also use delay and level of service. What we have endorsed as well in our, as an innovation in our methodology, is the possibility to set priorities amongst modes. Because in our discussions we said a city normally endorses a sustainable urban mobility plan, and this sustainable urban mobility plan, it has certain targets, objectives that shall be put into practice, and one of those political priorities that are endorsed in those sustainable urban mobility plans may be the fostering of cycling, for example. And if this is the case, then obviously congestion for cyclists is more important than congestion for car drivers or pedestrians. So we can put a weighting factor into this calculation process. Here in this lower table, this is just an example. We have put the priority on cyclists with a weighting of 3, and I will explain in later slides how we incorporate this into the calculation process. All right, and here we are already at step number 3, the calculation of those 3 indicators and the aggregation of them. So again, this is now the delay indicator. Again, we apply it for junctions and for corridors, and we apply it at a junction by calculating the mean delay on the turning movement per lane and per transport mode in seconds per person. And we say person, we don't say vehicle, so we have to apply for, at least for the car, we have to apply an occupancy level and multiply it to the number of vehicles with this occupancy level, which could be, for example, 1.2 or 1.3, and then we have the mean delay in seconds per person. So that's an important part of our multimodal assessment, that we do not calculate vehicles but people. And the same is true for the calculation of delay at the corridor. This is the difference between actual and minimum travel time in seconds per person. I already explained this. The minimum travel time, it's not the ideal travel time, or at least not for the bicycle and for the pedestrian. There we apply the acceptable travel time. Yeah, full stop. And again, if you have questions about that, we can discuss later. I will just go through the slides. Density, it's usually calculated in vehicles per kilometer, or persons, in the case of pedestrians, persons per square meter. And then that has to be transformed into persons per kilometer. This is the density indicator, if we assess a segment. And then we have the level of service as a derived indicator, which can be applied for a junction, a segment, and for the corridor as well. For a junction, it's based on the mean delay per transport mode. For the segment, it's based on the density. And for the corridor, you see this figure on the right-hand side of the slide. There is the different, you can see a hypothetical street network with different junctions, and for each and every junction you can apply the level of service calculation, the level of service calculation. And this is a nice graphical representation. So along a certain corridor, you can see which junctions have a good level of service indicated in green or in yellow, and those which do not have a good LOS indicated in darker red. All right. How do we derive those LOS numbers? There we have to distinguish again between delay and density. In the upper level you can see, in the upper table you can see the different classes, LOS classes for delay. So for example, if there is a mean delay as measured in seconds per vehicle of cars, then which is below 20 seconds, then we have LOS A. And that also applies for the other modes, this kind of transformation. And then we receive a certain number of utility points. For example, the level of service A leads to 110 utility points. We have to keep this in mind for the calculation process, for the aggregation process, which I will explain in a second. The same procedure is conducted for density. Here we have different units for different modes, but all assessments lead into a certain number of utility points depending on the level of service. Again, A is 110 utility points and F is 10 utility points. And then we have calculated delay, density, and LOS. These numbers, these utility points that I was mentioning in the previous slide, coming from the table, which is basically given from those technical guidelines that I mentioned in the beginning of the presentation. They will then be transformed to something which we call a multimodal performance index. So now we are at the stage where we have calculated the congestion index, if you like, for mode specific, for each and every mode under the assessment. And we now calculate an aggregation of all modes. So the first step is, again, calculation of mode-specific variables in our units. For density, that may be vehicle per kilometer or persons per square meter. Delay, seconds per person, and level of service is those different distinct classes from A to F, those 6 classes. We transform this into mode-specific variables into the same unit, which is utility points of level of service. And then we aggregate those utility points into one multimodal index, whereas we apply 2 weighting factors. And the first weighting factor is the traffic volumes, and the second weighting factor is the priority factor set by the city, which I was mentioning already. Um,
I'm going to interrupt you just
Okay.
briefly. We're getting close to the end of our time, and I'm wondering how much longer you need, and
No, I'm
put the
through.
question out to everybody if they're willing to give us 5 extra minutes of their time today. Okay, I'll just put that request out and let you to finish now. Sorry, Fred, I just want to let you know we're getting close to the end of our time.
Yeah, it's yeah. Sorry, I had to speak a long time to explain this, but again, this will be can be discussed in more detail during the e-learning course.
We give you a really difficult task.
Yeah. So, yeah, 3 slides left. So we do this aggregation by using utility points per level of service per mode and calculating the mean utility points. LOS, E, and F are usually considered as undesired and congested. So the value of 40 or less could be considered as congestion by a city, but again, this is up to the city to decide whether that is desired or undesired. And here on this slide, I try to give you an example how this aggregation procedure works, and we have another example in our e-learning course as a task, which is provides more slides and more explanations. So we have a level of service for the car, for the pedestrian, for the car driver, for the pedestrians, and for the cyclists. In this hypothetical example, that would be LOSD for the car, C for the pedestrian, and again C for the bicycles, leading to 50, 70, and 70 utility points. Then we have this weighting factor, which is hypothetic. We put emphasis on the bicycle. We have also the traffic volumes given as a second aggregate, as the second weighting, and that would lead to a multimodal performance index. You can see this in the orange block on the right hand side of 60 utility points, meaning this is LOSD, as you can read here in this table. Yeah, and that's the methodology that we developed. Just to conclude, it calculates the performance and capacity of each transport mode independently. First, whereas the indicator delay is evaluated on a person basis rather than a vehicle basis, following the premise of moving people and not moving vehicles. Then we offer an aggregation procedure, which I tried to outline in the last slides, to create something which we call the multimodal performance index, indicated as level of service. We provide the option to apply a weighting in the aggregation process so that the index can be adjusted to reflect the strategic priorities of the cities endorsed in the sum. And last but not least, we take into account the user perspective by endorsing the principle of minimum or acceptable travel times. Yeah, that's it. Thank you.
Okay, thank you very much, Fred. As I said, we gave you a big challenge, I think, by asking you to present the methodology in a relatively short period of time. So we probably should apologize both to you and to our listeners. It's a lot of information to take in, but we probably consider this also as advertising for the e-course, which we are starting as soon as this webinar is over. It's running for a 4-week period, and we'll be going into more detail into all of the components that we talked about here today. We have time for a couple of questions, I think, just before we go. We're running a little bit behind our schedule, but I think we can still take 1 or 2 if we have anybody that would like to put questions out. We can also happily provide written responses to people afterwards, and or continue this conversation in the e-course that will be starting, as I said, today.
Okay, we do have one question that's come in already, and this was actually from earlier from Peter. Dijok. May have pronounced that wrong, but the question is, are you restricted to PTV for using the findings of this project, or can you also use open source tools like MatSim? And if so, how? For example, is it a downloadable library?
The clear answer is no, we're not restricted to PTV products. We have PTV as a project partner. But obviously you can also use MatSim, that's not the problem. MatSim is able to calculate delay density and level of service, and thereby you are definitely able to apply our methodology with MatSim.
Thanks, Fred. Any other questions, Kristen, that we should address right away?
No other ones have come in the meantime, and there's no hands raised at the moment. So
okay, then we'll take that as at least covered for the moment, or I hope people interested in taking the online course which is coming up. And to that end, Kristen, do you want to take the screen for just about a minute and a half and give the quick overview of how people can register for the online course if they're interested in taking that over the next 4 weeks?
yes, absolutely. So here we go. And I'll just minimize everything. Okay, so yes, today starts our very first e-learning course. I suppose I can show my video as well. Hello everybody, you haven't seen me yet. And so the registration process is actually very simple. You would just go directly to our e-learning platform, and that's mobility-academy.eu. You click on Create a New Account right here. And then it will take you to a registration form to create your new account. Just fill in the areas that we're requesting and click this button at the bottom. And then you will receive a confirmation email. Maybe check your spam folder just in case. Click the link here in your email to confirm your account. And then you'll just need to return to Mobility Academy. And after that point, you can just log directly in at any time to access the courses. And you'll see there are some other courses available to you, but right now we're just talking about Flow. So you want to scroll all the way down to the bottom right and click on the Flow folder. And then click on this one course that's available right now. Click Enroll Me. Then you receive another nice confirmation email, maybe in your spam folder. And at that point, you're able to access the course if you just log in again. You can optionally add more information on your profile page, but we don't require that because you'll be introducing yourself in the course. And this is what the course will look like once you log in. There'll be a bit more at the bottom, but yeah, this is what you'll be able to access. So yeah, we hope that all of you will be able to register, and that we'll see you on the news forum and the discussion forum, and continue the discussion, ask any questions that you weren't able to right now.
Yes, and as you can see from the smiling faces, Kristen and Fred will be moderating the course over the next 4 weeks. And we also will include the link to the starting point that Kristen talked about in a follow-up email that you'll be receiving tomorrow. So you know the information is coming. We'll send you the link, and you can just follow the few steps that are required to get you registered for the course. And it runs for 4 weeks. We'll be opening it up immediately after today's webinar, so we can get started then. And we look forward to continuing the conversation with you there. But meanwhile, thank you very much from Cologne, from Wuppertal, and from Dublin. And we wish you all a pleasant afternoon. Thank you and goodbye.
Goodbye, thank you.
Bye.